Unit 2 is IS-2, Heat and Energy in the Earth System. You'll be learning many vocabulary terms throughout this unit. Cross-cutting concepts is anything that has applications across all domains of science, such as physics, biology, or chemistry. The system is the focus of your study. In other words, the thing you care about. Surroundings. The surroundings is everything else outside of your focus. In other words, the things you do not care about. Universe, the system and surroundings. Exothermic means heat is leaving the system. Since the heat is going down, or the amount of thermal energy in the system is decreasing, we put a negative symbol next to the letter Q. Q is the variable for heat energy. Endothermic is the opposite. Heat is entering the system. There is always both exothermic and endothermic when energy transfers. Energy is a property of both matter and radiation. By definition, energy is manifested as the capacity to perform work. For example, causing the motion or interaction of molecules on a microscale, or on a macro scale, the movement of machines or planets. Energy is a cross-cutting concept. You will be learning the laws of thermodynamics. There were originally 3 laws of thermodynamics, but a 4th law was created after the first 3 were made. The 0th law of thermodynamics states, if 2 thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. Equilibrium means that there is no observable change. This particular law is used to show how a thermometer works. The first law of thermodynamics states the total energy of an isolated system is constant, and that although energy can be transformed from one form to another, it cannot be created nor destroyed. This law is also called the law of conservation of energy. There are 3 types of systems. An open system is where mass and energy can be exchanged. A closed system prevents mass but not energy from being exchanged. And an isolated system is where no energy or mass are exchanged. Here's a picture of the 3 types of systems. Open has no cap or lid, so water, in this case matter or mass, can be exchanged, which means go in or out. Heat can leave because the bottle, in this case, is not insulated. A closed system has a cap, preventing any mass or matter from escaping, but heat can go in or out. And isolated means capped and insulated, preventing anything from leaving or going in. The second law of thermodynamics states, an isolated system always progresses toward thermodynamic equilibrium with maximum entropy. Isolated system was talked about previously. Maximum entropy. Entropy is in reference to disorder. The third law of thermodynamics states, the entropy of a perfect crystal is 0 when the temperature of the crystal is equal to absolute 0. Entropy is a measure of disorder. A perfect crystal would not have any disorder when the temperature is equal to absolute 0. Absolute 0 means the temperature at which there is no movement of any atoms or molecules. Physical states of matter. Matter, by definition, is anything that has mass or weight. Weight is mass with gravity, and takes up space or volume. Density is the ratio of mass and volume. The units for density is grams over milliliters, or grams per milliliter. Matter tends to float when its density is less than the liquid. The math formula for density is D equals m over v. People tend to remember this formula by thinking of the Department of Motor Vehicles, DMV. Here's an example math problem for density. What is the density of an object that has a mass of 10.0 grams and 11.5 milliliters? The formula is D equals m over v. M is mass, which in this case is 10.0 grams, and volume, V, is 11.5 milliliters. If you divide 10 and 11.5, you get 0.870, a rounded number. The units stay as grams over milliliters or grams per milliliter, just like in the fraction previously. There are 4 states of matter. There are 3 major ones, and the 4th one, the last one in this discussion, is not considered a major one because we don't see it very often. The first one is a solid. A solid maintains its shape and volume. A liquid changes shape to the container but maintains volume. And a gas changes shape and volume to the container's size. Plasma is an ionized gas. The best example of plasma on Earth is one of those pink and electricity balls that you might see in a hobby store, where if you touch the glass, you'll see the electricity touch your hand. There are 3 types of energy transfer: conduction, convection, and radiation. Conduction is where a solid object tends to get warm by touching another warm object. Convection is usually the movement of liquids, and radiation is some sort of release of energy into the air. Here are the more detailed definitions. Conduction. Heat is directly transmitted through a substance when there is a difference of energy between adjoining regions, without movement of the material. This is usually for solids. Convection is the movement caused within a fluid by the tendency of hotter and therefore less dense material to rise, and colder, denser material to sink under the influence of gravity, which consequently results in transfer of heat. The best example of this is to look at a lava lamp. Here's a video of a lava lamp being shown and the narrator explaining the convection currents.
This video is about convection. The item in the video is a lava lamp. Inside it are 2 different liquids. One of them is basically water. That's the clear liquid. The blue liquid is an oil or wax. It's heated up at the bottom just by a lamp, a light bulb essentially. And that is heating up and melting the wax. When the wax melts, it becomes less dense. As it becomes less dense, and as the liquid around it becomes less dense by being heated, the particles spread out. Therefore, they rise. The particles of the water rise and carry up the wax. So, as you can see, they're congregating at the top. But when they're at the top, they're not next to the lamp anymore, so they cool. As they cool, they fall. That's a convection current, and it's all due to the changes in density due to the changes in temperature.
The last type of energy transfer is radiation. Radiation is the emission of energy as electromagnetic waves. Usually we see electromagnetic waves in the form of light or radio waves or microwaves or things of that nature, or as moving subatomic particles, especially high energy particles which cause ionization. This is the same type of radiation such as in nuclear energy.